Hello, my dear students. Last class explained about static formulae and for how it can be used for cohesive soils. Today, let us discuss about finding the ultimate bearing capacity or allowable load for non-cohesive soil. So, RF is equal to K into tan phi into gamma z plus Q. Okay, here RF this one, and RP is equal to zero point 0.3 gamma B N into gamma Q for circular piles, and RP is equal to R into B divided by 2 N gamma Q. This is for rectangular or square piles, where K is coefficient of lateral earth pressure. All of you know this. What is coefficient of earth pressure? Okay, gamma is density of soil and Q is surcharge on the ground, and Z is depth of center of gravity of the pile below the ground surface, and B is least lateral dimension of rectangular or square pile or diameter of circular pile. Phi is angle of internal friction, and N gamma Q, that is Mehra's non-dimensional factor, that is bearing capacity factor. So using this equation RF and RP, you can find what is the ultimate bearing capacity. So I think all of you know these terms now, are all familiar with these terms. So if you substitute the respective value of these terms, you get what is RF and RP. So here one you have to note down, RP for circular pile is different and RP for rectangular and square piles are different. Okay, and here to find this N gamma Q, that is Mehra's non-dimensional factor or bearing capacity factor, this can be calculated using this graph. Okay, if you have D divided by B ratio, and if you have phi dash value, you can calculate what is N gamma Q. Okay, so this graph is bearing capacity factor versus D by B ratio. So if you have D divided by B ratio and phi value, you can find what is bearing capacity factor. Okay, here this is earth pressure coefficient, this side is earth pressure coefficient, and this is also earth pressure coefficient. Okay, so this is phi is 30 degree and this is phi dash is equal to 40 degree. And here figure 1 this figure gives the curves for N gamma Q for various values of K and D by B ratio, that is depth. D is depth of the pile, for phi is 30 degree and phi is equal to 40 degree. This is for 30 degree, this is for 40 degree. The use of these curves necessitates the determination of the coefficient of earth pressure K, which is a very variable coefficient. Okay, so using this D divided by B ratio and K value, you can find what is N gamma Q for the different values of phi. Next, let us see what is the piles, how to find the bearing capacity of the pile in C5 soil. There is both cohesion as well as friction. So for that, where the soil has large values of both C and phi, as for a true C5 soil, we should use the conservative Terzaghi's bearing capacity factors to determine the load carrying capacity. So this is the formula to find the bearing capacity of C5 soil. Qu is equal to AP into CNC plus sigma VB into NQ plus 0.5 gamma D N gamma plus summation of Ni is equal to 1 AS into alpha C plus K into sigma V tan phi, where NC, NQ, N gamma are Terzaghi's bearing capacity factors, and sigma VB and sigma V, that is effective overburden pressure at base and pile shaft, irrespective of the critical depth. Now, let us discuss about pile load test. Now, I have spoken about this static formulae and dynamic formulae. So, next one is pile load test. The pile load test can be performed either on a working pile, which forms the foundation of the structure, or on a test pile. Okay, so it can be performed on either on the working pile or maybe on the foundation of the structure or on a test pile. The test load is applied with the help of calibrated jack placed over the rigid circular or square plate, which in turn is placed on the head of the pile projecting above the ground level. The reaction of the jack is borne by the truss or platform, which may have gravity loading, or alternatively the truss can be anchored to the ground with the help of anchor piles. In the latter case, under-reamed piles or soil anchors may be used for anchoring the truss. Both the arrangements are shown in figure. You can see here, this is the jack loading. Okay, the loading is done by jack, that is reaction by loaded platform. Here, the jack loading, that is reaction by the anchors. Okay, so here the gravity loading to take jack reaction. Okay, so these are the sandbags are kept here, and waste that provides the load. Okay, so this is a jack. Here you can see this is a jack, and this is a test plate, and this is a pile. Okay, so these are the supports provided. So this is about reaction by loaded platform, and here this is through the trusses or anchors. So this is a reaction truss through which the load is passed into the passed to the test pile. This is a test pile. Here you can see these are the soil anchors. Okay, so the load is transferred through the soil anchors. These are the anchor piles. Anchor piles. The load is applied in equal increments of about 1/5 of the estimated allowable load. Here, how to apply the load? It is in equal increments, about 1/5 of the estimated allowable load. The settlements are recorded with the help of 3 dial gauges of sensitivity 0.02 mm symmetrically arranged over the test plate and fixed to an independent datum bar. A remote controlled pumping unit may be used for the hydraulic jack. Each load increment is kept for sufficient time till the rate of settlement becomes less than the 0.02 mm per hour. The test piles are loaded until ultimate load is reached. Usually, the test load is increased to a value 2.5 times the estimated allowable load, or to a load which causes a settlement equal to 1/10 of the pile diameter, whichever occurs earlier. Okay, so here the test load is increased to the value of 2.5 times of the estimated allowable load, means 2.5 times of QA, or to a load which causes settlement that is equal to 1/10 of the pile diameter. So which occurs earlier, that value will be taken. The results are plotted in the form of load settlement curve. The ultimate load is clearly indicated by load settlement curve approaching vertical. If the ultimate load cannot be obtained from the load settlement curve, then the allowable load is taken as follows. Usually the ultimate load will be obtained from the load settlement curve only, but sometimes it is not possible to get the ultimate load using load settlement curve. In such cases, the following points, based on the following points, the results can be obtained. That is, the first one is 1/2 to 1/3 of the final load, which causes settlement equal to 10% of the pile diameter. Okay, 1/2 to 1/3 of the final load, which causes settlement that is equal to 10% of the pile diameter. Second point is two-thirds of the final load, which causes a total settlement of 12 mm. Next point is two-thirds of the final load, which causes a net settlement of 6 mm. So these 3 points are also used to estimate or find the ultimate load. Next, so these are all about pile load test. Okay, here main thing, the load is applied, okay, either through the anchors or through the gravity. Then the load is continuously increased, and corresponding settlements have to be noted down. So based on the load settlement curve, you can find what is the ultimate load. If it is not possible to find based on load settlement curve, you have to consider these 3 formulas to find the allowable load. So this is about pile load test. Next, let us discuss about penetration test. The results of Dutch cone penetration test can be applied with sufficient accuracy to determine the ultimate bearing capacity of piles in cohesionless soils. The following relationship may be adopted, that is Rp is equal to Qc, or Rf is equal to 2 of Fc, where Qc is unit resistance of Dutch cone penetrometer, Fc is static skin friction on the shaft of the penetrometer. I explained about what is penetrometer, what is static cone penetration test and all in bearing capacity chapter. This is the Qc is Dutch resistance obtained by the Dutch cone penetrometer, and Fc is static skin friction on the shaft of the penetrometer. Here also, based on this some points, you can find what is the ultimate bearing capacity. The static cone penetration test data and standard penetration test data are often used to determine the pile load capacity. The point resistance of driven piles in sand, including edge piles, can also be determined using N values as per the below equation. That is QPU, the allowable bearing capacity or resistance, that is equal to 40 times of N into L divided by D kilonewton per meter, where N is the standard penetration resistances observed in the field for bearing strata without the overburden corrections. So this is about penetration test. Now let us discuss about pile groups. What is pile group? Means it is a group of piles. Here, the structures constructed on pile foundation is usually on groups of piles because of the tendency of the pile to move laterally during driving. Piles are generally used in groups with a common pile cap. A group may consist of 2 or 3 or as many as 10 to 12 piles depending on the design requirements. When several piles support a load together, the total resistance derived from them is generally different from some of the individual pile load capacity. One of the various factors which affects the load carrying capacity of pile is the spacing of the pile. Closely spaced piles develop overlapping of the pressure bulbs, which leads to the reduction in load carrying capacity of piles. If the spacing is more, the cost of the pile cap increases enormously. So this is about pile groups, means it is a group of piles. It may be a single pile or 2 piles or 3 piles or like as many like 10 to 12 piles depending upon the design requirements. Okay, here which offers these all these piles support a load together, so the resistance offered from them is generally different from the individual pile load capacity. But here the main thing you have to remember, spacing plays a very important role. So if the piles are closely spaced, then it causes the overtapping of the pressure bulbs, and so which leads to the reduction in the load carrying capacity of the pile, and also the cost of the pile cap increases enormously. So you have to avoid that. So the spacing that can be calculated using the IS code method that I will explain in the next slide. I hope all of you understood. Thank you.